share my screen again, and then go through Canvas so that you guys can see what's going on. So under Canvas, you guys are in Zoom, but the place where you want to go is under modules, because the modules is where you're going to find the experiment. So I'm just going to click there, and first you could hit these chevrons or code chevrons to close the windows so that it's easier for you to navigate to the pertinent material. Anyway, we are now on week 8. That's the 24th through the 26th. So you want to click on that. Last week we had no class. So when you click on that, this is what you will see. Actually, you don't see this. You see this? Something's happening again. I apologize for that. Go back. Computer skipping all over the place. Okay, let me make this bigger. These means that I've published these pages. This pages is not published because this pages is just the old page I had before we went online. So this page, which is really the PowerPoint slideshow of my pre-lab discussion, you'll be able to see it again in the following pages. Anyway, let me go back. Okay. So always click on module because Canvas has a way of getting you to different pages. We are here. What you want to do is just go through this, and I've sort of ordered it here so that you go into sequence. The first page right here tells you when it's due and the points for that particular lab. And if you click on that, in fact, what I need to do is go into student view so I see what you see. So I'm going to do that. I'm going to go under student view. And this is what you guys will be seeing. I'm going to go to the 8th week. See that other page, because it was not published, is not showing here. Okay. If you guys enter the room, go ahead and mute your microphone. Otherwise, everyone will hear what you're saying. Okay. So here is experiment 6, and experiment 6. This right here will tell you. Let me just do a preview. That basically is the PowerPoint that I present. No, this is the description of the experiment. So I put everything online in terms of the experiment. I'm going to minimize that. This right here is the PowerPoint that I usually present at the beginning of class. You have to download it, and then it'll open as a PowerPoint slideshow. Okay. And the slideshow is generally what I show you during class. So let me just do that real quick so that it won't take long. This lab is to determine the empirical formula of 2 compounds using 2 different methods. One of them is magnesium oxide. Another one is a copper chloride compound. Your job is to identify the formula based on the data that's given. Never, well, this doesn't really pertain because you guys aren't doing the experiment, but if you were doing the experiment, don't touch hot objects and do not look at the magnesium burning, and do not use excess zinc. These are the pre-lab questions. This is what happens if you took copper and reacted with sulfur. And I think this was discussed in your pre-lab material, in your laboratory material. This is a sample calculation of how you would do most of the calculations here. You've got 4.482 grams of nickel reacts with oxygen to form 5.093. And you assume that the 5.093 is the mass of the product. There are no other impurities in that particular material. Calculate the empirical formula. So if you have the mass of the nickel, which is 4.482, and the mass of the metal nickel oxide, then the difference between the two, the difference between the two, 5.093 and 4.482, is the mass of the oxygen. Now you have the mass of the nickel, which is this, and the mass of the oxygen. It's just a matter of calculating how many moles these things represent. So if you take 4.482, which is the mass of the nickel, and divide by the molar mass, atomic mass of the nickel, you get the moles of the nickel. If you take oxygen and divide by the atomic mass of oxygen, which is 16, not 32, okay? Make sure you understand that. Oxygen, the atom, is 16, and we're using oxygen, the atom, in this calculation, not 32, the molecule. If you do that, that's 0.032. What you need to do is you need to get these numbers, 0.0764 and 0.0382, into whole numbers. So what you do is you divide both of these by the lowest value, 0.0382, and you get a ratio of 2 to 1. So the formula that you have for nickel is Ni2O, because that's the empirical formula. And if you've got 2 nickel for every oxygen, an oxygen has a charge of -2, and you should know that because oxygen has 6 valence electrons. It needs 2 more electrons to get an octet. Therefore, its charge is -2. Then nickel has to have a charge of +1 since you have 2 nickels. That's the formula. Okay, so that was a sample calculation. Here are examples of reactions that are carried out for part A. You have magnesium, you burn it in oxygen. You have magnesium, it also burns in nitrogen. Why? Because air, which is the other ingredient in this reaction, is also, nitrogen also is in air. So basically what will happen is that you will not only get a magnesium oxide compound, you also get a magnesium nitride compound. What you need to do is you need to remove the magnesium nitride and convert it to magnesium oxide. That way you get all the magnesium converting over to product. So that's what this reaction shows you, okay? And so here's a sample calculation. If you start with 2.43 grams of magnesium and your magnesium oxide product, and you don't know the formula, although you probably do, is 120.060, then, and 120.060 includes the mass of the crucible, by the way, then what is the empirical formula? So that's just some sample value, and I'll show you how to do that calculation shortly. You guys are going to use a crucible. You guys are going to use a Bunsen burner. You guys are going to look at the Bunsen burner, and you've already used this, so it should not be strange to you. Then you guys are going to heat up the crucible. Okay, you're going to heat it up so that it's clean. That's how you clean the crucible, by the way. You open it up slightly so that any material in there is oxidized. You're actually going to heat it up and then weigh it. So that'll be the mass of the crucible. You don't just take the crucible and weigh it directly because there's got junk in there. So that's why you're doing this prep of the crucible. Once you have this, then you take magnesium. You clean it to make sure that there's no oxidation, because the metal is going to oxidize at the surface. So you got to clean that away because that's impurities. You put it in the crucible, you heat it up, it'll ignite, and it's going to make magnesium oxide and magnesium nitride. Okay, so here's an illustration of that. You open it up so that the air can go in and combust with the magnesium. You add a little bit of, remember in that reaction what we added? Let me go back so that you guys can see that. In the reaction that occurs, you add water so that the magnesium nitride is going to be converted to ammonia and you get magnesium oxide. So in that particular procedure right here, you guys are going to be adding a little bit of water to remove the magnesium nitride and convert everything to magnesium oxide. But in this particular, again, I'm kind of like, you guys aren't doing the experiment, but if you were, that's what you would be doing, okay? You add the water, and then everything converts over, you cool it, and then you weigh it. So this is a sample data table, okay? If I was conducting the class, I would have you guys run the experiment 3 times. In the data that you see, you only run the experiment twice, okay? It's always good if you're going to be a scientist, if you're going to do an experiment, to always do it 3 times, even if the procedure says 2, because when you do it 3 times, you can get a reliable average and you can do statistics with the data, which is always what you want to do with experimental data. Anyway, here's what the data presents. I've got 2.43 grams of magnesium. The mass of the crucible and cover is 120.060. The mass of the crucible, cover, and compound is 124.0690. So the mass of the compound is basically the mass of the compound and the crucible minus the mass of the crucible and cover, which is 4.030. So magnesium is 2.435, the product's 4.030. Here are other data for the other 2 trials. So what you want to do is now, like in our nickel calculation, figure out how much oxygen is in this compound, this 4.03. So you take 4.030 and subtract the mass of the magnesium, 2.435, and you get 1.600 grams of oxygen. Now we want to convert those to moles. So the way you do that is, let me take my pen here. You take the mass of the magnesium and you divide by the atomic weight of magnesium and you get the number of moles magnesium. You take the mass of the oxygen, you divide by the atomic mass of the oxygen, you get the moles of the oxygen. You can see that it's a 1-to-1 ratio. So that's the formula that you get. So the second part of this experiment is a solution chemistry reaction. You take zinc and you react it with copper chloride. And this reaction that you see right here, I'm going to change my color. Okay, let's go with blue. This reaction that you see right here is what we call a single displacement. The zinc kicks off the copper. The copper now is the free element and the zinc combines with the chloride. What happens is that the chemical reaction by which this takes place is zinc, copper, and hydrochloric acid, and you would get that. So the reaction calls for about 20 mils of copper chloride. It's blue because copper ions are generally blue. The solids are generally bronze, but when you convert it to its ionic form, that is its charged form, it's generally blue, powder blue. So in this reaction, we're going to add hydrochloric acid and you guys are going to get this chemical and you guys are going to figure out that formula based on the data. So this is the experimental flow chart. You get your chemicals ready. Copper chloride, graduated cylinder, you weigh the amount of zinc, this is zinc, that you're going to be introducing. You put the zinc in the copper chloride and you watch the reaction takes place. That zinc, which is sort of silvery gray metallic, will now turn brown on you, okay? And then what you want to do is collect the precipitate, dry it, and then weigh it. Then you're done with the experiment. Experiment's pretty easy. These are typical data table. You've got 1.01% mass volume percent. So from the mass volume percent, if you know the volume, you can calculate the amount of copper chloride in the reaction. And I'll show you that shortly. You've got the mass of the zinc that was weighed out and the mass of the copper. So these are sample data. So how do we get 0.130 grams of copper from 1.01%? Well, we got that based on the fact that we can take the percentage and the volume, and if you take the percentage and the volume, then that'll give you basically the amount of copper that you have. So when you do that, these are the mass of the zinc and the mass of the copper. Okay, so the mass of the copper minus the chloride minus the mass of the copper is 0.202, and that's minus 0.130, that's 0.072. The next thing we want to do is now convert the mass of the copper to most of the copper using the atomic weight. And then we also convert the mass of the chloride to most of the chloride using the atomic mass of the chloride. So this is basically your calculation, and that would be based on that information. Based on that information, you guys should be able to get the mole ratio and therefore get the chemical formula. So that basically is the experiment that you guys will be doing, and then you have some post-lab questions. So let me go ahead and see if there's any questions there. You guys have any questions out there on terms of the pre-lab? Now that you've seen the material, the pre-lab material, let's go back to this. Okay, then the rest of the lab here is basically the same as when you're in, as if you were in the lab. Let's go over here. The pre-lab quiz. It's a 10-minute pre-lab quiz. Take the quiz, okay? It's actually, I have it, you should do it sometime today, but it's not due until the 27th. So I actually put a due date here of the 24th because that's when we regularly meet, but you can do it all the way up to the 27th before midnight, okay? So again, it's basically 5 or 6 questions, it's multiple choice. Let me just give you a preview of what it looks like. This is basically what the quiz will be. It's what is the empirical formula? While the magnesium is burning, what should you do? What element is added to the copper chloride to produce elemental copper, etc. Okay, this is the post-lab quiz that you guys will see. So I'm gonna go ahead and get out of there. You have 10 minutes to answer those questions. But since you've already seen the questions through this video, then you have more than 10 minutes. But just make sure that from the time you open it to the time you submit it, you do it within that 10 minutes time frames. Otherwise, it won't accept it. Okay, so that's the pre-lab quiz. The pre-lab questions are basically the same questions that you see in your lab manual. I'll give you a preview, except I've made it easier for you. I've taken those questions and I've made it a multiple choice question. What, instead of you guys just kind of writing out an answer, I give you choices. What color is the most commonly associated with solutions of copper compounds? What is the likely formula for a compound between magnesium and oxygen? Write the IUPAC name for CuCl2. So those are the pre-lab questions that you find in your lab manual. Let me get out of here. So you answer those two, okay? And again, because it's an online format, it's not mandatory that you go on the order that's presented here. You just gotta complete everything by the 27th. So you guys have more flexibility there. Let's move on to the main body of your experiment. That's this page right here. It's the video, it's the data worksheet, and the data. This is where you're going to find the information you need to write the data and your observations to answer the data worksheet. So this is a YouTube video of, and let me just show you this real quick. I'll give you a quick preview. Sorry about that. there's always commercial in the beginning. Anyway, this right here is the experiment.
Magnesium, and this is pretty easily done.
Except he needs to be wearing gloves.
Our crucible, and then we'll get the mass of our crucible, cover, what's our lid, okay?
Anyway, you guys can watch it at your leisure, okay? I'm going to minimize that video. So that's part A. This is part B. So again, it's just a matter of making sure you have the you have access, and then you can start here. And I'm going to go ahead and go fast forward this so that you guys can see what's going on.
Chloride from the weight of the copper chloride hydrate. The mass of copper was found experimentally. Finally, the mass of chloride is found by subtracting the mass of copper and water from the total mass of the sample. To determine the smallest...
Let me just show you the experimental procedure.
Which is indicative of the anhydrous form of copper chloride. Stir to make sure that the water has been driven off and the color is consistent throughout. Next, cool the sample in a desiccator to prevent rehydration.
So let me go ahead and stop there. You guys are going to watch the movie in its entirety. And then down here, part C. So A is part A, B is part B. C is your data sheet. So you can do a preview of the data sheet. And this is basically the same data sheet that you guys have in your lab manual. Sorry, I take that back. The data sheet is the data that you would use to put down in your lab manual. This is the mass of the magnesium, the mass of the crucible and cover, the mass of the crucible cover, and compound. So you have two trials. All you're doing is calculation for two trials. The copper chloride, well, you basically have the 1% solution, 15 ml volume. In my pre-lab discussion, I used 20. The mass of the zinc, the mass of the copper. Okay, so this is the data that you guys would put in your data worksheet. So this is where you would get all the information. Let me get out of here and then go back to where we left off. So that's empirical formula, video, data, worksheet, and data. Now we go to the data worksheet link. Here you would be completing your lab in your lab manual. And once that's all completed, then this is where you submit it. And I'll give you a preview of this. It's basically a file upload question. Please upload the data worksheet for experiment number 6. You find your file. The thing about Canvas is that the file needs to be one document. So if you've got multiple pages, Canvas will not allow you to do that. Let me get out of here, okay? What you need to do is you need to zip that file or copy the pages into a Word document or convert it to a PDF, because if you have multiple pages, you're not allowed to upload multiple pages. It can only upload one file. So you've got to either compress those pages into one file or copy and paste those pictures into one file. What you want to do, of course, is write your report as if you were in class and then take a photo of it. And the photo needs to be legible so I can make sense of the data that you're putting in. And the data that you're putting in is basically the data that you see from the previous link. So it shouldn't be that difficult. Anyway, you upload your data worksheet here and then submit it. And then see how if I go back on this breadcrumb, it takes me to the wrong page. I don't want to go to that page. I want to go back to module. And I want to go back to week 8. And then this is where you upload your post-lab questions. Take a look at the deadlines. All these are on the 27th. Even though this says the 24th, you have up to the 27th to turn that in. And these are the point values for the different portions. The pre-lab quiz is 5 points. The pre-lab questions is 10 points. The data, that's less points because you guys aren't actually doing the experiments anymore. So that went from like 15 to 20 points down to 10 points. And now the post-lab question is going to be more heavily weighted. So click here after you answer the post-lab questions, and then submit your worksheet in this particular page, okay? So that's basically it. The way you carry out the lab for the rest of the semester is for you guys to go to the weekly modules, that's this, and run through each one of these, especially the video, data worksheet, and data, and it will basically have that consistency. And you just go through the lab as if you were in the classroom, except of course you guys aren't doing the experiment. Next week is spring break. After that, we have a midterm and lab practical. Here's a study guide for that midterm. And then the 11th week, the 14th through the 16th, we do the next experiment, which I believe is going to be experiment number 7, okay? So let me get out of this share screening and let's see if you guys have any questions. But otherwise, that's what the experiment is about.